everybody, welcome back to Club Phoenix. My name is Remy Jagakar, and today we're going to be learning about the 4 fundamental forces of nature. So, the 4 fundamental forces of nature are gravity, the weak force, electromagnetism, and the strong force. Now, today, because the weak force and the strong force are very complicated subjects, we're only going to be learning about electromagnetism and gravity. But I highly encourage you to learn about these other forces in your own time. So without further ado, let's get to it.
So, let's talk about gravity first. I'm sure that many of you are familiar with it, but let's get further into it. Gravity is an invisible force by which any physical object that has a mass ranging from planets to people draws objects towards its center. Gravity is shown when you jump but then come back down. That is the Earth pulling you towards its center. What's really cool is that all objects attract others using gravity, so in a way you are pulling the Earth towards you. But it's not even microscopically visible because you are too small to move anything towards your center using gravity. So, the greater the mass of something, the greater the gravity it has. Also, gravity gets weaker with distance. For example, when you jump on Earth, the gravity is very strong because there is a comparatively small distance between you and the Earth's core. But if you were on Mars, Earth's gravity would not greatly affect you because you would be so far away. Of course, it is important to note that the force of gravity exists for an infinite distance. So the gravity on Pluto has the effect of us right now, but it is so small that there is no way it can be measured. Overall, gravity holds the entire fabric of the universe together, which is why it is considered one of the 4 fundamental forces of nature. The electromagnetic force is an attraction between the subatomic particles. I know this sounds like a mouthful, but let me give you a quick refresher. An atom is the smallest unit of an element, and it is so small that it's not even visible to us with microscopes. They are referred to as the building blocks of life. All atoms are made up of subatomic particles called protons, neutrons, and electrons, which are shown in this diagram. See in the middle? That is called the nucleus. The nucleus is made up of protons and neutrons, while the electrons are in the outer layers of the atom. This is referred to as the orbitals. Protons have something called a positive charge, neutrons have no charge, and electrons have a negative charge. Different atoms can have different numbers of protons, neutrons, and electrons to look unique, which is why a desk isn't made out of the same substance as water. Protons have something called a positive charge, meaning they push away other protons but attract electrons. Electrons have a negative charge, meaning they attract other protons, but repel other electrons. Remember, opposites attract. Neutrons have no charge, meaning they do not attract or push other protons away. If you take a deeper dive into this, you will see that there are 2 components to the force. The 2 components to this force are the electrical component and the magnetic component. When these particles interact, the electrical component helps the subatomic particles influence each other, and the magnetic component turns the area between them magnetic. So, when electrons zoom through a wire to charge your computer or phone, or to turn on your TV, the wire becomes magnetic. The little gap between the charged particles is where photons, which are a bundle of energy, travel, and they're sort of the main element of the electromagnetic force. Because these photons are so small, scientists have no idea what they look like, but this is their best guess. Because of the interaction between subatomic particles, the photon number increases, and they hold everything that we can actually see, such as physical items, together in a shape. They are basically what gives shape to the universe.
I know that today's lesson was a little bit harder than our usual lessons, so I highly recommend that you guys go ahead and read on this independently because it's honestly a really cool topic. So today's activity is going to be a lot easier, and even if you didn't understand much from the video, that's okay because I'm sure you're going to have so much fun finding the center of gravity and making a new friend along the way. So, the center of gravity is simply the point where the mass, which is the stuff that things are made from, of an object is concentrated. I could try to explain it, but I feel like why don't we just do the activity and you guys will find out for yourselves. Here's the link to the sheet that we're going to use to do our activity today. So, you should have the sheet printed out now, and we're going to be using it to construct a new robot friend whose center of gravity we're going to find. So, I would like you first to cut out these 2 robots. Once you finish cutting them out, go ahead and color them. For the sake of time, I only colored in one side, but you can do both. Now what I want you to do is take a piece of cardstock or any just hard paper that you have. If you don't have it, that's okay, but I highly recommend it. And I want you to cut it so that it fits on this figure. It should now look like this, and I would like you to glue it in place. Make sure that you only do this for one side. Once you put the cardstock or whatever material you have on your robot buddy, I want you to take a penny, and then on the other side, stick glue or tape or putty, whatever you have, and stick it on the robot's arms, like that. Glue all over here, or tape, whichever one you have, and stick it on like that. So now you should have your little guy done. And what I want you to do is take your finger and try to balance him. The point where he balances is his center of gravity, which is right there. I encourage you try to find his center of gravity using a pencil, even try to put it on your nose, get crazy. Anyways, I hope you enjoyed today's lesson, and remember to come back for next time.
Hey guys, welcome back to Club Phoenix. My name is Rhea, and today we're going to be doing the walking on water experiment. First, we're going to need 3 clear cups. I'm going to use these plastic cups, paper towel, scissors, food coloring, and water. Okay, let's get started. Begin by cutting the paper into half. Fold one piece in half lengthwise, and then fold it in half lengthwise again until you have a strip of paper towel. Do the same with the other half. It should look like this when you're done. Take the cups and line them up in a row. Fill the outer cups halfway with water. Make sure to leave the middle one empty. Then add a few drops of food coloring. Make sure you add 2 different colors to the cups. Now place one side of one of the paper towel strips in a cup with water and place the other side into the middle of the empty cup. Do the same with the other paper towel strip on the other cup. Now wait for the magic to happen. Watch as the colored water walks up from the outer cups into the middle cup through the paper towel strips. A few of you might be wondering how and why this happens. This occurs because of a process called capillary action. The water travels through the holes in the fibers and the paper towel into the empty cup. This process is also used in real-life scenarios. For example, it helps water climb from a plant's root upwards to reach the rest of the plant and the leaves. Okay, I'll see you guys next time. I hope you enjoyed the experiment. Bye!
Hello everyone, my name is Swaksha Mehta, and today we're going to be doing a candle vacuum experiment. So let's get started. For this experiment, you're going to need a bowl. Make sure it's not paper. You're also going to need an empty glass and a glass filled with water and a small candle. If you want to make this experiment extra fun, you can choose to add some paint or food coloring to your water. Once again, this is optional, but I chose to add some red paint to my water. After mixing in the red paint, this is what my water looked like. The next step of this experiment is to add your water into the bowl. For the second step of this experiment, you're going to need an adult to help you light the candle. After your candle is ready, ask an adult to help you place the candle into the center of the bowl. Here, I'm just going to add a little bit of extra water so that the water level is halfway to how high the candle is. This is the most exciting part. Grab your empty glass and flip it over and place it on top of the candle. As you can see, the candle is creating a suction and it's pulling all the water inside of the glass. This is what the candle looked like up close. So you might be wondering what exactly happened. Why did the water level rise? The water level rises inside the glass because the candle is heating up the air inside the glass, which means the air inside the glass now has a higher pressure because of the heat. And the air outside the glass has a lower pressure because it's not exposed to the heat. So when the air inside the glass cools down, it creates a partial vacuum effect which suctions up the water, causing the water level to rise. But this does not last for a very long time.